Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome you all the students for our chemistry lecture. Hope you all will be fine and studying well. As we have started chapter number 9, that is elements of group 13, 14 and 15. This is our fifth lecture for the same. Today student we are going to study bonding in compound of group 13, 14 and 15 elements. Here, the lighter elements in group 13, 14 and 15. The lighter elements means the one which is having low atomic number. So as they will be having low atomic number, they will have small atomic radii and high ionization enthalpy value. As we know, atomic radii is inversely proportional to ionization enthalpy. If the elements having small atomic radii, they will be having high ionization enthalpy. Fine. So, these elements will form covalent bond. What is covalent bond? A bond is formed between an atom by sharing of an electron, that is your covalent bond. So they form covalent bond with others atoms by overlapping of valence shell orbital. Here, the valence shell orbital of one atom will overlap with the another valence shell orbital of another atom. So they will form covalent bond. As we move down the group, as we are moving down the group in the respective group 13, 14 and 15, the atomic radii will increases. As atomic radii will increases, their ionization enthalpy will decreases. Fine. So, here the atomic radii increases since the valence shell orbital are more diffuse. The atomic radii will increases. Okay, find down the group. As the atomic radii is increasing, their ionization enthalpy will decreases. Hence, the valence shell orbital will be more diffuse. So here, the heavier elements in these group, in the group 13, 14 and 15, they will tends to form ionic bond. The lighter elements in these group will form which bond, student? They will form covalent bond. While the heavier elements will form ionic bond. Okay, the bond formed between ions. Okay, the first member of these group belongs to second period and do not have d orbital. Boron, carbon and nitrogen cannot expand their octet. Okay, these elements, the first member of the elements of group 13, 14 and 15, they will be similar to the second period and do not have d orbital. Fine. So here boron, carbon and nitrogen, they cannot expand their octet. Then the substituent elements in the group possess vacant d orbital in their valence shell. Rest of the elements will possess vacant d orbital in their valences, which can expand their octet, forming a variety of compound. Fine. The rest of the elements they can they possess vacant d orbital, due to which they expand their octet and forms a variety of compound. Fine. So here student, the lighter elements will form covalent bond. They are having small atomic radii, hence high ionization enthalpy, while the heavier elements having high atomic radii, hence low ionization enthalpy, and they form ionic bond. Fine. So here student, the first member of these groups, they belongs to second period as they do not have d orbital, due to which they cannot expand their octet, while the rest of the elements they possess vacant d orbital in their valence shell, due to which they can expand their octet and hence forming a variety of compound. Let's move towards reactivity towards air or oxygen. Elements of group 13 on heating with air or oxygen, they produce oxide. Whatever the elements of group 13, when it is being reacted with oxygen, they get converted into respective oxide. E means element. You can take any of the element of group 13. Fine. So any elements of group 13, when it is heated with air or oxygen, they get converted into respective oxide in the form of E2O3. So here the reaction has been given 4E. 4 is the number which we have assigned to get stable the reactant. Okay, E means any of the elements of group 13. When it is being reacted with O2, that is your oxygen, arrow has been there. On the arrow a triangle mark is there. A triangle mark suggests you that the reaction is being heated. Okay, so these elements, when it is being reacted with oxygen on applying heat, it get converted into their oxide in the form of E2O3. Fine. So here E is their elements plus O2. It is in gaseous state. It is being heated and it get converted into E2O3 in the form of solid. Okay. So 4E plus 3O2 give rise to 2E2O3 on applying heat. Below that, the reaction has been given with nitrogen. So it get converted into nitrite. 2E plus N2, nitrogen existing, N2 existing gases in state. So on heating, it get converted into 2En. En is your any of the elements, it get converted, it is reacted with nitrogen and on applying heat, it get converted into respective nitrite. So this is the reactivity towards oxygen, and for nitrogen it has been given for group 13 element. Let's move further towards reactivity of group 14 elements with air or oxygen. The elements of group 14 on heating in air or oxygen form oxide. It also will form oxide, but in the type of EO and EO2 with respect to the stable oxidation state and availability of oxygen. Okay, yet the two criteria is there: oxidation state and availability of oxygen, due to which these elements and on reaction with oxygen get converted into respective oxide, okay, in the form of EO or in the form of EO2. Let's see the reaction. E means any of the elements of group 14. When it is being reacted with oxygen, half O2. Here half 1 by 2 into 2. It leads to solve the student. 1 by 2 into 2. It leads to 1. So when this E, when it is being reacted with half O2 and on applying heat, it get converted into EO. Okay. Next reaction, E, that are any of the elements of group 14, when it is being reacted with O2 and on applying heat, it get converted into EO2. Fine. So this is the reaction of the elements of group 14 with air or oxygen. Let's move further towards the reaction of elements of group 15 with air or oxygen. So here student, the elements of group 15 on heating in air or oxygen form two types of oxide. Here they form oxide in the form of E2O3 and E2O5. So here two types of oxide is formed when these elements of group 15 it is being heated with air or oxygen. First type is E2O3 and the second type is E2O5. So let's say the first reaction P4, that is a phosphorus, okay, plus 3O2. O2 is your oxygen. When P4 is being reacted with 3O2, arrow, on arrow it is been a triangle sign. It has not been given because we are applying heat. So it get converted into P4O6. So it is in the form of E2O3. Why? Because 4 and 6, when it is divided by 2, it get converted into 2 2s are 4, 2 3s are 6. So it get converted into the form of E2O3. Fine student. So P4 plus 3O2, it get converted into P4O6 in the form of oxide E2O3. Next reaction P4 plus 5O2. Okay, when it is being heated, it get converted into P4O5 divided P4 and 10 by 2. 2 2s of 4 and 2 5s of 10. So it is in the form of E2O5. So P4 plus 5O2, arrow on the arrow mark the sign of heating, it get converted into P4O10. Next reaction is with arsenic As 4 times, okay, plus CO2, apply heat, it get converted into As4O6, which is in the form of oxide of E2O3. Next one is your bismuth, and this is your last one. Bi, 2 molecule of bismuth, when it is being heated with 3O2, it get converted into Bi2O3. So here is the reaction of the elements of group 15 which on heating in air or oxygen get converted into two types of oxide. First one is your E2O3 form and the second one is your E2O5 form. So your student increases in metallic character down all these groups as we are moving down the group 13, 14 and 15. The metallic characters of the elements is being increases, which reflect their oxide, which gradually vary from acidic to amphoteric to basic. Fine. So their oxide will gradually vary from acidic to amphoteric to basic. We are going to see the table 9.6. The nature of stable oxide from group 13, 14 and 15, which will be given in table 9.6. Here is the table which state nature of stable oxide of group 13, 14 and 15. Now for group 13, boron, aluminium, gallium, indium and thallium. These elements in their respective oxide form. As the metallic characteristic is increasing down the group, this boron in oxide form will having acidic in nature, where aluminium they will having amphoteric in nature. Gallium further it will be having amphoteric in nature. Indium in their oxide form will having basic in nature, while thallium in their oxide will having again basic in nature. So here the one which is having acidic in nature from group 13 is your boron, and the one which having amphoteric means which is having an intermediate properties of means it possesses the properties of acidic as well as in base. Okay, so it consists depending upon the one which to whom it is being reacted. So the one which having the properties of both acidic and base is your amphoteric in nature. So we have been studied this whole thing in the other chapter in detail, so we are not going to study that thing over here. So boron is having acidic in nature in their oxide form, while aluminium and gallium in their oxide form will having amphoteric in nature, while indium and thallium in their oxide form will having basic in nature. So we are moving further towards group 13, in which carbon in an oxide form is having acidic in nature, Silicon in its oxide form is having acidic in nature. Germanium in an oxide form is having acidic in nature, while tin and lead in an oxide form is having amphoteric in nature. So from group 14, carbon, silicon and germanium in their respective oxide form having acidic in nature, while tin and lead in their respective oxide form is having amphoteric in nature. So let's move forward towards group 15, in which nitrogen in an oxide form is having acidic in nature, phosphorus in an oxide form is having acidic in nature, arsenic in an oxide form is having amphoteric in nature, as antimony in its oxide form is having amphoteric in nature, bismuth in an oxide form is having basic in nature. So here nitrogen and phosphorus in their respective oxide form is having acidic in nature, while arsenic and antimony in their respective oxide form is having amphoteric in nature, and bismuth in an respective oxide form is having basic in nature. So here student, we have studied nature of stable oxide of group 13, 14 and 15 elements. Hope you all have understood. Revise the lecture. Study well student. Do your best. Thank you.